All right, so we are going to go ahead and get started with the Eccentricity of Orbits Lab. It is officially the last lab that you're going to do this year. It's the last official lab. We will still be doing some reviewing because we still have your lab practical to get ready for, but this is the last lab of the year. So as always, do the reading. Sorry. Answer the checkpoint questions from the reading, and then now we're going to go ahead with the procedure. So the procedure starts with, and as you can see, I'd already told my group that you all needed a piece of cardboard and this little Petri dish. If your Petri dish is still taped shut, that was just for convenience for me. So you can go ahead and open it up, and inside the dish, you should find a string tied together. If your string is not tied together, it needs to be, and you should find 2 pins. Please don't be idiots with the pins. Yes, they're sharp. Yes, you could poke yourself with them. Yes, you could hurt yourself. Don't. I am not doing the paperwork. Okay. No, don't. So you do need those supplies. And as you can see, steps 1, 2, and 3 have already been crossed off because it says cut a piece of string to about 25 centimeters in length and tie the ends together to form a loop. I did that for you because over the last 14 years, I realized this was the hardest part of the lab, was kids tying a string. So I just gave up and did it for everybody. Then the next part took too long. So on a plain sheet of white paper, lightly draw a straight line down the center of the paper horizontally and draw a dot at the center of this line. You may have noticed the last sheet of paper, I did all of that for you. Because again, that was harder than it should have been for people. So go ahead and actually physically rip it off though. I do want you to rip it off. Okay, if it went front and back, that's just because my marker bled through. There should just be the back that looks like this. So you have already completed steps 1, 2, and 3 of this procedure. What did you ask? Should we rip it off? Yes. Technically, you don't have to rip it off, but you're not going to be able to do 2 things at once if you don't. So go ahead and rip it off. All right, guys in the room, just stay with me for a few more minutes. Here's what we're going to do. So it says place the paper on a piece of cardboard and stick the 2 T-pins into the dot. The T-pins should be touching each other. So you're going to take your pins, hold them as if they were one, and stab them into the dot. No string yet. So both of them into the dot. Now I'll just tell you, once you get them stabbed in there, don't wiggle them around. Don't try to go through the desk too. Just get them in there nice and firm, but don't wiggle them because then you'll make the hole bigger. We don't want that. Now you've done step 4. Does everybody have their pins in the paper looking like mine? Step 5, loop your string around the pins. So you're just gonna put your string around the pins. And now this is gonna mess with some of you. I like using this type of pen, a ballpoint pen. Pencil works. But what you're going to do is you're going to kind of get your pen in that string. And here's where, kind of like drawing the earthquake circles, you have to be both gentle and firm at the same time. So you're going to pull the string nice and tight, but not too tight that you pull your pins over. And just draw yourself a nice circle. Now, some of you might go off the paper depending on how big your string was, but it's okay. So you should now have drawn yourself a perfectly beautiful circle. So once you've drawn your circle, you did step 4 now. Step 5 says, no, I'm sorry. You did step 5, you just did not label it yet. I would like you right on the line to label it circle. No, it has to be labeled circle.
I messed mine up.
Okay, we'll come back to the mess ups in a second. I want to keep going. What have we done wrong? It's perfect. The label, you mean? That's fine. Let me see what you guys messed up. Nothing. I think that's gorgeous. So you can see that like I had a little, because the paper or the cardboard's a little ripply. My circle looks a little ripply, but it's okay, guys. We don't all have to be perfect like me. So again, like I said, we have done steps 1 through 4 now. 1 through 5. Step 6. In this, the distance between the 2 T-pins. How far apart were those 2 T-pins in centimeters? 0 centimeters. So we need to record this on our report sheet, round this to the nearest 1/10 of a centimeter. So our report sheet looks like this. The D stands for distance. Distance between 2 foci. So for the perfect circle, and it did say to round to the nearest 10th, so I do need the 0.0 for the perfect circle. Now, the L, according to the formula, stands for length of the major axis. The major axis is basically, and actually we're there too. So we already did step 6. Step 7 says to measure the major axis, which is the diameter of the circle. Record your answer on the report sheet, again, round to the nearest 1/10 of a centimeter. So there are rulers scattered around the room. You do have to measure this in centimeters. If the pins are in your way, you can carefully remove your pins. Don't stab yourself. So everybody's is going to be different. You all had different strings, so your diameter is going to be different. I don't know. Mine's 19.4, but again, everybody's circle is going to be different. Classroom, can you guys focus and be quiet for just a little bit? Okay, well, so mine again was 19.4 centimeters. And right. So I then tell you in the direction, so you've now done step 7. I guess I don't tell you to calculate till you're all done doing this. So you can just leave it like that, or you can come over here and start doing the math. Now I do ask you for the formula. What is the eccentricity formula? No, what is the formula? First, it's the distance divided by the length of the major axis. So then I ask you to substitute those numbers in. So we have 0.0 divided by whatever your length is. And what is 0 divided by 0, or 0 divided by anything? Now I'll tell you the directions say to round this to the nearest 1,000. So what is 0 to the nearest 1,000? And what are the units? Nothing, because centimeters on top, centimeters on bottom, they cancel each other out. No, I will let you hear for the formula for all the rest to E equals D over L. You can plug that in. But yes, I am expecting to see your math here. Nope, not quite yet. Now we get to the weird spot. We are on step 8. It says move each T-pin out 1 centimeter from that dot and draw the ellipsis following. So what that means is here's the dot where your T-pins were before. We now need to move each pin. One of them goes 1 centimeter to the right and the other goes 1 centimeter to the left. Again, it has to stay on the line. One goes 1 centimeter to the right and one goes 1 centimeter to the left. No, I just said they have to stay on the major axis. Guys, you're going to get confused if you don't pay attention now. So did you move your pins? Now, in theory, how far apart are they now? Technically, they should be 2, because if you went 1 centimeter to the right, 1 centimeter to the left. But remember, when you're measuring, you legit just have to measure, because you could be like 1.2 or I'm sorry, 2.1 or 1.9. So make sure you measure that when we get there again. So you're gonna do the same thing. Grab your string now that they're about 2 centimeters apart. Draw a new shape around there. So you can see it doesn't have to be absolutely perfect. My pen skipped a little. But you now have a new shape there, and it does say to label this ellipse number 1. So I'm just gonna go with the number 1. You need to go ahead and do the math again. And then you're going to get to step number, where does it say which one we're going to do this over and over again? Step number 14 says you're going to do it all over again. Move the pins out another centimeter each time and go until you have all 4 more ellipses drawn. So you have a circle and 4 ellipses. You'll do the math for everything, remembering to round correctly for each one. 10th place for the distances and the length, 1000th place for the eccentricity. Every time you do it, you move the pin out 1 centimeter to the right and the other 1 centimeter to the left. So you're going to keep spreading the pins apart. Any more questions? When you're done with this, you will still have the conclusion and the post-lab questions. Make sure everything's complete before turning it in.